Yes, hello, my dear students. Welcome back once again to the St. Joseph Composite PU College, Vijaypur. I'm Rahul, and in this present video, I just want to explain you that a variation of molar conductivity. Okay, the first, try to understand that what is molar conductivity. If you've gone through with my previous video, you have seen that what is conductivity. I was explained very successfully. I took a more time to explain the conductivity in the previous video, but this time I will just concentrate on the molar conductivity. If you know the conductivity very well, then only you can come to know that what is molar conductivity. Now, one important thing that the difference between the conductivity and molar conductivity is that in the conductivity we are considering a very small volume of the solution, in that whatever the number of ions are there, they are responsible for the conductivity. But in the molar conductivity you have to take entire solution which containing 1 mole of ions or 1 mole of electrolytes in general. Okay, now let's understand this with a diagram. This will really help us. Okay, now let me draw a container here, some sort of container it is. Okay, I can't draw here 3 dimension, but I can draw here only 2 dimension, but you can visualize it. Assume that this is a cube, but it's not. It looks like a square. It's a front side view. It is a cube. Now, along with that, there are some lines are there that showing that. Let me show that also. So these are the some lines. I divided the solution into small cubes with a unit volume. Let me do it. So the entire solution is divided into a small volumes. Okay. 2 more lines I have to draw. Okay. Now this is a cube, and you just visualize it's a cube, and this is the smallest portion of the cube. This is the smallest portion of the cube. Okay. The conductance produced by the smallest cube is taken here as a K. That is called as a kappa. That is generally called as a conductivity. Conductivity. Okay. Now, like this, a small volume of the solution is conducting a certain ions or behave as conductors. Now it's showing some conductivity. Like that, we have to take here n number of conductivities. Like that, we can place here k in all directions. Okay. Instead of that, you can just multiply with the volume. Yeah. This is a small volume, and this is entire volume. Take this entire volume as V, capital V. Okay. And this is a conductivity produced by a smallest volume. And therefore, I will write here lambda m is a term used for the indicating the molar conductivity, and then it is given by K, that is a kappa, the conductivity given by a small volume of the solution, and multiplied by entire volume of the solution. This equation is called here as the molar conductivity. This is called as a molar conductivity equation for molar conductivity, which having the terms conductivity and entire volume, which containing 1 mole of solute or electrolyte. As we know that solution containing here contain 1 mole of electrolyte. Obviously electrolyte may be strong or weak, whatever it is, we'll discuss that later. So here the solution containing 1 mole of electrolyte in a volume V. The V will be the volume of the container. K is conductivity. So K is a conductivity. Now, as we know that as you do the dilution, the volume increases. On dilution, you look at the formula. Okay, at the formula you will see that the volume term will be there. On dilution, the volume is increasing. Volume is increasing. As the volume is increasing here, obviously the molar conductivity, which is directly proportional to the volume. Therefore, this implies here increase in molar conductivity. Okay, hope you got at this point. The molar conductivity is increased because the volume is increasing here. Okay, now we can observe here 2 type of effects. The one effect is on the weak electrolytes, the other effect on the strong electrolytes. We'll observe the difference in the effects. The first part of discussion is effect of dilution on on the strong electrolyte. Strong electrolyte. Okay. First, we have to understand that what is strong electrolyte and how the molar conductivity is varies in a strong electrolytes. Okay. Now let me take a container here once again. This time I will take a small container. I don't want to divide it. There's a container or some cube is there. In this, if I use a strong electrolyte, there are many number of ions are there. Strong electrolyte because they are completely get dissociated. These are the strong electrolytes which are completely dissociated. I have to take one more ion here, some other color. Okay, let me place ions here. Okay, I got it. See, so as these are very strong electrolytes and they are completely dissociated, strong electrolytes, electrolyte, and they get complete dissociation. Complete dissociation. Okay, this is, we know that this complete dissociation, number of ions are more in a solution. Okay, as there is complete dissociation is there, means large number of ions are produced. Large number of ions. Ions present. Presentable rate. I don't want to write here produce a presentable rate. If large number of ions present in a certain volume of container, then the distance between the oppositely charged ions is very less. Therefore, I will write here the inter-ionic distance. Ionic distance is there. It is very small. Distance is small. As the distance is small means the ions have started attractions. They have still attractions in them, and because of that, the movement of ions becomes less. The movement of ions become less. As we know that the conductivity depends upon how the mobile ions are there, how easily they can move. If the ions are moving very rapidly, then the conductivity is more, right? If the ions are moving very slowly, very restrictedly, then the conductivity is very low. So therefore we can say that the conductivity is low here. Conductivity is low. So I'm talking here conductivity in a small volume, students. You got it, right? In a small volume conductivity. You're not talking about the molar conductance. On dilution, something happened here. On dilution, as you increase the volume, the distance between the ions are also increased. On dilution, interparticle or inter-ionic distance increases gradually. It's not sudden. Okay, it increases gradually, because as you go on adding the water, slowly the ions get separated out. Slowly the distance between the ions is increased, and therefore the movement of ions slowly get increased and conductivity also get increased. Okay, here the inter-ionic distance increases. As a result, inter-ionic attractions decreases. Decreases gradually. Let me write here gradually. As the attraction decreases gradually, the movement of ion becomes more or increases gradually. The movement of ions increases gradually. If the movement of ion is increasing gradually, the conductivity is also increases gradually. Or in general I will write here molar conductivity. Directly I will write molar conductivity increases gradually. Hope you understood this, students. So this is for the strong electrolytes. If I take a graph, if we discuss this with a graph wise, so this is a graph where we are using a strong electrolyte. So like KCl is a strong electrolyte, and this side is a molar conductivity, and this side if I take a square root of concentration, then the decrease in the concentration leads to the decrease in the molar conductivity, right? This is all about, but let it be, it's not important for us. It's a gradual decrease. In the next video I'm going to discuss how the molar conductivity varies with a weak electrolytes on dilution, right? Till that, thank you for watching.